Hello, Year 12, Extension 1. Exercise 5D now actually looks at the complete calculation or definition for the coefficient, which is, which is defined in terms of NCR and is actually called the binomial theorem. This is the binomial theorem that NCR, the coefficient, used in a binomial expression that comes from Pascal's triangle, is defined as n factorial over n minus r factorial. Now, we're not going to, we'll eventually see the proof of this, but for now, we're just going to be working with it and becoming really familiar. This alternate way of explaining or defining the binomial theorem comes from, I guess, n factorial being n times n minus 1 times n minus 2 times, and this time we will include n minus 1 more than r and n minus r, then all the way down to times by 1 all over n minus r factorial, n minus r and times n minus r plus 1, sorry, minus 1 because we're going down, subtract 1 from that, times all the way down to 1, times r factorial, which is r times r minus 1, or just r factorial, which is equal to, we've got n minus r plus 1. So all of the rest of that goes, and all of this goes. So we've got from n down to 1 more than r, n minus 1 more than r. So it's n times, I won't write it because you can see it here. N times n minus 1 times ... down to 1 more than n minus r, because the n minus r factorial component of the top has been cancelled with the denominator, and they've just chosen to write r factorial in reverse. We've seen before that we can write a binomial expansion in sigma notation in terms of the coefficient times r. Now that's a very simple situation, because you'll note that in your binomial, one of your components is 1, and has to be for this to be true, and the coefficient of the x is a 1. So that's not going to happen in the majority of cases. This is a fairly simplified specific case. We look in a little bit more detail at variations and complications where we no longer just have a 1, and in reality you'll see that if x has a coefficient, that also must be taken into account. But in sigma notation, the expansion would be the sum r equals 0 to n of NCR as one component of the coefficient, a to the n minus r, and again, if a is a number, a numeral, then that will also contribute to the coefficient. If x has a coefficient, then that will contribute to the overall coefficient, and obviously then the term x to the r. So you're going to see that right now in this expansion, or in this example, where we're writing that in sigma notation. We'd have, it's the sum r equals 0 to, in this case, 5, of 5cr 2 to the 5 minus r, and then minus 3x to the 5. And if you think about that, 2 to a number is going to be also part of the coefficient, and this negative 3 to the power 5 will contribute to the coefficient. Now, I'm making rather a big deal about what the coefficient is, because if you look ahead, you'll see the next exercise is talking all about the actual coefficient in the expansion of binomials. And unfortunately, very few of them are going to be this simple, where the coefficient is just only contains the NCR component. Okay, just a few things, and again, this is all really just setting you up for the style of question that you get asked, which really starts in the next exercise and the one after that. The general term, the r plus 1th term. Now remember that we said in a plus x to the n, there will be in total n plus 1 terms in total. So if I'm talking about the r plus 1th term, we would expect it to be NCR and have x to the r and a to the n minus r. Just getting a handle on that concept is really important for the next exercise, because we're going to be talking about finding the greatest coefficient. So if we want to say the greatest coefficient is the 4th term in the expansion, the 4th term won't be NC4. No, the 4th coefficient would have a component of NC3, because remember we start NC0. We start counting from 0. So try to be aware of that in all of these questions you do, and because it will provide good foundation for moving into the next concept. Some other properties to be aware of, which we proved in a previous exercise, is that NCR is NC n minus r, that it's reversible, and this property as well. Okay, let's have a look at a couple of examples. Solve. 9c2 minus nc1 is equal to 6c3. So when you look at that, hopefully you're bringing to that much of the basic maths you know, which is if you see a solve, you're finding the value of the pronumeral. So in this case, you're finding n. Just like if you're finding any unknown that's contained within an expression, you might want to single it out. And so I would suggest that that be the very first thing you do in this case. So you actually write this more as 9c2 minus 6c3 equaling nc1. That then gives us a numerical statement to work with, and then we will equate it to NC1. Having a good understanding too of NC1 will tell us that, well, from Pascal's triangle, we've got 1, 1, 1, 1, 2, 1. We know that, and 1, 3, 3, 1. We know that all the coefficients in the first position all the coefficients in the first position actually reflect the value of n. So if we could work out what this number actually is, it represents the coefficient in the first position of the row, then it actually also reflects the value of n. Okay, let's work on 9C2 minus 6C3. So there you can see, just to save a bit of time, I've actually done the calculation. 9C2, 9 factorial, 7 factorial, 2 factorial. I've simplified that, cancelled out as much as I can. Did the same with 6C3, cancelled it down, got the numerals 36 and 20, subtracted them and got 16. Now, if 16 is NC1, we know terms in the second term in the expansion has the same total value as the power, therefore n is equal to 16. Example 2, it says use the general form of one of the properties of Pascal's triangle to find the value of n. If we have a look at this, we can see we're talking about the fourth term, the fifth term, then being equal to the fourth term. So the fourth term, fifth term, the fifth term. These two values here are the same. This is taking us to this property right here where we've got the fourth term and the fifth term, or the fourth and fifth coefficients of the fifth row, and we know they would equal the fifth coefficient in the sixth row. You can write your answer straight down as n is equal to 6.